So from these computations, we can know cotangent x approaches infinity as x approach 0 from the right. And cotangent x approaches negative infinity as x approaches the pi from the left. And as in the case of the tangent x, the shape of the graph of cotangent x between the 0 and pi is repeated, okay, between each pair of the consecutive asymptotes. And also, the period for the cotangent x is equal to pi, okay, same as tangent x. And you can see the range of the cotangent x is just the set of all real numbers. So the range, this is from the negative infinity to positive infinity. And also, the cotangent x is decreasing in each cycle. For example, here, when x increases from the 0.01 to 0.02, the y value decreases from the 100 to 49.99, right? And then to 1 to 0.58 to 0 and to negative number. So cotangent function is a decreasing function. And we also have the 3 key points for the cotangent function. Let's put the the 3 key points is pi over 4, 1, half pi, 0, and 3 pi over 4, negative 1. The fundamental cycle this is from 0 to pi. Now, with all those order pairs and all those properties about the cotangent function, we can draw the graph of the cotangent function. So let's first plot the vertical asymptotes for the cotangent functions. So we know cotangent function has the vertical asymptotes at x equal to k pi, right? So k is equal to 0, then the vertical asymptote is the y-axis. So this guy, yeah, axis. And then at the pi, right, this is another vertical asymptote at 2 pi. At negative pi, okay, and in the fundamental cycle, we have this several we have the 3 key points. So this is the half pi 0, and here this is the pi over 4 1, and this is the 3 pi over 4 negative 1. Then we can draw the graph of this tangent function. And you can also draw the graph of the tangent function for some other cycle. See here. And also here. So the shape of the tangent function between the 0 and pi is repeated in each consecutive vertical asymptotes. Now let's graph the 2 cycles of this function. And determine the period.